Hello everybody. So in the last video we were studying back propagation and we were doing some actual calculations like some maths, right? Arithmetic. So this was the situation. Just quickly we'll see that we had, this was our input layer. So we had x1 as 0.05 and x2 as 0.10. Then we had like one hidden layer, which was h1 will be output of the sum, and then when you put it in the activation function, it will be h1 final, and here also it will be h2 final. So this video is not independent, so you have to go back and watch video 8 for this thing if you want to watch this video, because we have started there already. Okay, and this is our output layer, and we have some weights, right? These are our initialized weights, and our aim was to update these weights using the process of back propagation. And you see, this was our target variable, right? T1, y1 was supposed to have the value 0.01, and y2 was supposed to have like actual value, which we have in our training set, 0.99. And we did the calculations, and we found out that the value of h1 depending on these parameters is this. H1 final is this. What is the difference between h1 and h1 final? H1 final is this activation function operating on h1, and the activation function we took is our sigmoid function. Okay, so this is 1 over 1 plus e raised to a minus x, right? So, and h2 value was this one, h2 final was this one, this is our y1, this is our y2, this is y1 final and y2 final. So these are the outputs which the current neural network or multi-layer perceptron is giving us, and we were expecting these outputs. T1 should be 0.01 and T2 should be 0.99, and now you can compare these two and you can see that you are far from actual values. So we calculated error, and then error was this mean square error. So we have the target value minus the predicted value square plus the target value minus the second target value and the second predicted value difference square. You got your error to be 0.2984, right? So this is what we have done already in the last video. Now what is our aim? Aim is that we have to update these weights, right? So these are not the weights, these are the inputs, right? These are the inputs, but we want to update this weight here, this weight here, weight here, here, here and here, so that we should be able to get the target values, or we should be able to be very close to the target values. So now let us see how the back propagation works. So for back propagation we have our, what is the idea? Idea is that you have your total error, which we just calculated, which is defined as 1 by 2 T1 minus y1 final square plus 1 by 2 T2 minus y2 final square. Right? Now suppose now I want to update the weight wij, like any, suppose one first layer weights we want to update. So we will see how much, if you want to update this, if you want to update this weight, then you will see how much is this weight contributing, like this weight along with its nodes contributing towards the error, right? Now mathematically this quantity is nothing but, we can measure it as a rate of change of error with respect to wij. So we are looking for rate of change of error with respect to whatever weight you want to update, right? Now you understand that your total error, the final error you will get, it will be a function of all the weights, because weights are appearing in these calculations, right? So we will calculate this, and then we will update our weight as, suppose I want to update it, then the new weight will be whatever is my old weight, right, minus the learning rate eta times curly e total by curly wij1. Okay, so this means that what we are going to do here is the same thing which we did in our perceptron training. This is how you update, right? Okay, that makes sense. This is your learning rate. Okay, fine. So now let us see and why you do that. You see what you are doing. You are subtracting the learning rate times the rate of change of the total error with respect to that particular weight. So you are kind of trying to fine tune the weights with what actual output you are looking for, right? Okay, so now here let us suppose first I want to update the weight W112. Okay, so this is like I have done calculations for this particular weight. So what we will be doing here, so I am looking for curly E total with respect to W112. This is the first weight in the second layer, right? Now you see what is my E total. I already told you this is half of T1 minus Y1 final square plus half of, there are so many calculations, so I'm just telling you in advance. So we are going to do so many calculations, but this is only one time, and after that we'll see that how we have a very handy tool which can help us in all these calculations, right? Okay, so now I am looking for the derivative of this total error with respect to W112. So what will be that? Now you can see that what is E total is a function of Y1 and okay, here Y1 final and Y2 final, right? So what I can do is I can write it as curly E total. I'll use a chain rule with respect to Y1 final plus Y1 final with respect to Y1 and then Y1 with respect to W112, right? You see what we have here, we have like this, that E is a function of like this, right? This was your error was coming from Y1 final and Y2 final, right? And then this Y1 final, the weight was W112. So if I want to find the rate of change of error with respect to this, so this is the branch I'll go for. So I'll differentiate E with respect to Y1 final, then Y1 final. Before Y1 final there was Y1, that is just the activation function, and then you have your weight. Is this thing clear? So all these are multiplications. This is my chain rule, right? Sorry for the addition earlier here. This is multiplication. I hope that makes sense. Now let us see what is this your curly E total with respect to your Y1 final. From here you can see curly E total with respect to Y1 final is, you can just differentiate, right? So this is half into 2 times T1 minus Y1 final square, square will be gone, 2 minus 1 times minus 1, right? So it will be 2 and 2 will cancel, minus T1 minus Y1 final, and we already have the values. So this is minus 0.01 minus 0.75137514. Okay, so you will get this to be equal to 0.7414. Okay, so this is our curly E total by curly Y1. So now we got this first term, we calculated this already. Here we get the value 0.7414. Now let us go to the next term here. So for the next term we have to calculate the derivative of Y1 final with respect to Y1. Now if you look at Y1 final, that is equal to 1 over 1 plus e raised to power minus Y1 final. Okay, so the derivative with respect to Y1 would be, sorry, not Y1 final, here only Y1. So the derivative with respect to Y1, if you differentiate it, so what you'll get, you can just differentiate it. So this would be, you have minus 1 over 1 plus e raised to power minus Y1 square into the derivative of this particular thing here, which is minus e raised power minus y1. So this is e raised to power minus y1 over 1 plus e raised power minus y1 square. Now this quantity here is nothing but y1 final square. So this is e raised power minus y1 final square, right? We can actually use the value of y1 here and we can just find the value, but we can otherwise this quantity here is, if from here you'll see that e raised to power minus y1 is equal to 1 minus y1 final divided by y1 final, right? So this becomes 1 minus y1 final into y1 final square divided by y1 final. So this would be your y1 final times 1 minus y1 final. Okay, now you can just see we have this value already calculated from the last video. So this was 0.7514, and then you have 1 minus 0.7514, and the answer would be 0.1868. Okay, so we got this second term here. You see, everything is very easy. It's just that you have we got the second term and the first term already we calculated. So you just have to do some mathematics, like basic mathematics, not the advanced one. Here, this is the last term we have to obtain. So we have to write y1 first. Now you see, if you look at y1 is h1 final times w112 plus h2 final times w212 plus b2. How? You see, if you look at your neuron here, you see how you are getting this y1. Y1 is h1 times this weight, which is w112, and then h2 times this weight, which is w212, and then there is a bias term b2 also going, right? So that's why we are writing here h1 final times w112, and then h2 final times w212, and then your bias term. So if I want to find out the derivative of y1 with respect to w112, so this will be just h1 final, because we are working on the partial derivative. So this is 0.5969, right? Now you put all the values here. If you put all the values here, then the partial derivative of the total error with respect to w112 would be the multiplication of these three numbers. So that would be 0.7414 times 0.1868 times 0.5933. So that would be 0.0822, right? So this is your rate of change of total error with respect to w112. So we can update w112. The old value was, so we will be using this formula, the old value minus the learning rate. I am using it to be 0.5 times the derivative of the total error with respect to w112. So that is going to be 0.4, because the older value was 0.4 minus 0.5 times this value we just got at 0.0822, and this comes out to be 0.3589. So this is our new updated value. The earlier was 0.4, now the updated value is 0.3589. So similarly, we can update all other weights in this layer. So if you do the same process, you will get W21, the new value would be 0.4087, and W12, the new value would be 0.5113, and W22, the new value would be 0.5614. Okay, so what we have done here, you see, this was our error, right? Error was depending on this y1 final. Let me write like this so that we have more clearly. Y2 final here and y2 here, and then we have y1 final here, and we had y1 here, and this was connected to the weight w11, right? W11 to, right? Now and here you have your h1 final, okay, and here you have your H2 final, okay, fine. And here the weight is like I have drawn, the arrows are like this, okay. So here the weight is W2 2 2, and then from here to here you have weight W1 2 2, and from here to here you have weight W2 1 2. Now if I want to update this, or say this W212, W212 is here, so I have to follow this path, E with respect to this and then with respect to this, okay. So this is the path I have to follow, okay. Like we in the last case we followed this path like this, okay. Now you are going to follow like this, okay. So this is how we updated all the weights from the hidden layer to the output layer. Now if we go back further, so we have here, this is your H1, and then this is your H1 final, okay. And here you have your H2, and this is your H2 final, okay. And then you have your like this was my first layer, right? This is my x1 and this is my x2, and here is my weight W111, right? And suppose I want to just update this weight, so let us not like make it complex. Let us suppose I want to update this weight, so I have to connect everything. So I have the further is, it is y1 here and y1 final here, and here it is y2 and then y2 final here, okay. And then here it is the error E, right? Now if I want, now you see how this weight is coming into picture. What are the dependencies of this weight? So if you look at this thing here, you have we have to go like this from here to here, right? So you have to do E with respect to, right? If we directly go, suppose I want to differentiate E with respect to H1, the H1 final, and then H1 final with respect to H1, and then H1 with respect to this W111. So I will say my rate of change of the total error with respect to this weight W111 is going to be rate of change of total error with respect to H1 final, and then rate of change of H1 final with respect to H1, then rate of change of H1 with respect to W111, okay. So now let us try to see what it is, right? So here if you look at rate of change of E total with respect to H1 final, so what is that? That is rate of change of E total. E total we'll just write down in a moment. This is final. Then E total is 1 by 2 T1 minus Y1 final square plus 1 by 2 T2 minus Y2 final square, right? So now if we differentiate it with respect to H1 final, so what you are going to get, this will be your 1 by 2 into 2 times T1 minus Y1 final into curly Y1 final divided by curly Y1 into curly Y1 by curly H1 final. Here I have used the chain rule again. I had to differentiate Y1 final with respect to H1 final. So I broke it into two parts, and there is a negative sign also, right? Similarly, the next term would be minus 1 by 2 here. Minus 1 by 2 times 2 into T2 minus Y2 final. And then I will have the rate of change of Y2 final with respect to Y2, and then Y2 with respect to H1 final, right? So this would be, you simplify, this would be, this term here would be T1 minus Y1 final times the derivative of Y1 final with respect to Y1 into this thing plus, sorry, minus, this is also negative, and this here is also negative. So this would be t2 minus y2 final, and then you have curly y2 final with respect to curly y2, and then curly y2 with respect to curly h1 final. Right, now let us look at this term here, right? So did we calculated this already? Yeah, in the last video we calculated this number, so you can go back if you don't know. So this would be this was your 0.1868, and this here is 0.01 minus 0.7514 with a negative sign, and this will be curly y1. I'm just working on the first term, curly h1 final. So this is 0.13499 curly y1 time curly y1 curly h1 final. Okay, now this is the term I have to work on, right? So let us calculate this term here. So if you look at y1 final, if this is the term we have to calculate, right? Okay, this number I have written it wrong here. This is 0.138499, right? And then we have this curly y1 by curly h1 final. So this is the next task which we have to like compute. What is the value of curly y1 by curly h1 final? So if you look at this thing, so what is your y1 in terms of h1 final? You see y1 is w11, the second layer, h1 final, and then you have w21, the second layer weight, then h2 final, and then you have a bias term b2. So curly by curly h1 final would be curly by curly h1 final here, and that would be just this weight here. So you get w112, so that will be curly y1 by curly h1 final, right? And this value was our 0.40. Okay, so the first term here becomes, we have to just, this value is 0.40. Okay, so now we have our first term. Now let us look at the second term here. This is our second term, right? So if you look at the second term, we can put all the values here, and we know we want to find out these values. We know we have to find out this and this. So let us do that. So I want to find out curly y2 final with respect to, you can see here y2. Okay, so with respect to y2, so curly y2 final with respect to y2, so that would be equal to, if you do that, that would be equal to, can you think about what it should be? So you see that what is y2 final with respect to y2? It's just the activation function. So this is e raised to power 1 over 1 plus e raised to power minus y2. So that would be e raised to power minus y2 over 1 plus e raised to power minus y2 square, right? So that would be your e raised to power minus y2 final square, right? And this quantity we have already seen this again and again. So this quantity here is 1 minus y2 final over y2 final into y2 final square. So that would be 1 minus y2 final times y2 final. Okay, now if you put the values, so this is 1 minus 0.7729 into 0.7729, that is our y2 final. So if you compute it, so this would be 0.1751. Okay, and then let us look at this term here. This term, curly y2 by curly y2 by curly, we have to calculate h1 final, right? Curly, that is also very easy, curly h1 final, right? So what is that? That is curly by curly h1 final of, now you think about how y2 is being constructed. So for that you have the weight W12, the second layer weight H1 final, and then you have W22, the second layer weight H2 final, and then you have B2. So this, if you differentiate, this is what you are going to get. So that would be W12, the second weight, and that is 0.50, right? So you have your values here. You just put these values here. Okay, so if we put the values here, so this will be your T2 was 0.99 minus 0.7729. Then you have this value we just calculated as point, just now we calculated it, right? This value was your, this value we just calculated here. This is the value 0.1751, right? So that's the value, curly y2 final by curly y2. So the value is 0.1751. Okay, so we put it here 0.1751, and this value we just calculated it. This was the weight, this was your 0.5, right? Okay, and this value, if you add like just this number multiplied with this number and all these things, so if you just put the final things everywhere, so you'll get your curly E total with respect to, this was what we were computing, right? This was your curly E total with respect to H1 final. Okay, so that would be, this is just the first term we have computed yet. Okay, so this would be curly E total with respect to curly H1 final. So that is 0.03649. Okay, now let us go to the second term. The second term is here, the derivative of H1 final with respect to H1. This is easy. So derivative of H1 final with respect to H1. So that would be derivative of 1 over 1 plus e raised to power minus H1. So that would be e raised to power minus H1 over 1 plus e raised to power minus H1 square. So that would be e raised to power minus H1 final square, and that would be, right? And if we have already seen that this quantity is 1 minus H1 final over H1 final into H1 final square. So that would be your H1 final times 1 minus H1 final, and that would be your, you know the value of H1 final, 0.5933, 1 minus 0.5933, and this value would be 0.2413. So the next term was easy to calculate, right? So we just got our this term here. Okay, this term we got the value for this term. So this term we just calculated as 0.03649, and this term we calculated as 0.24130. Okay, now let us look at the last term. This is the term curly H1 with respect to the weight. So we have curly H1 curly W11 with respect to weight. So that would be curly. Now you think of how H1 is being constructed. So for the construction of H1, so you had the weight W111, and then you multiplied it with X1. Then you had the weight W211. Then you multiplied it with X2, and then you have B1. Now if you differentiate with respect to W11, this is what you are going to get, X1. So you'll get X1, and which is 0.05. Okay, so therefore our error, okay, with respect to W11 total, with respect to W11 is 0.03649. Then the second term is 0.2413. And the third term is 0.05. This comes out to be 0.00438568. Right? Now I will update this weight. W11 updated, okay, would be the old value of W11 minus the learning parameter times E total with respect to W111. So this would be, the old value is 15.15 minus the learning rate is 0.5 into this derivative is 0.000438568. So this comes out to be 0.14978. Okay, now if you updated all the value weights in this layer, so you'll get W11 new is 0.14978, W21 new is 0.19956, W12 new would be 0.24975, and W22 new would be 0.299950. Okay, so these are our updates, like for the weights. So these are the updated weights, and we already updated the weights for the second layer. Okay, here were the updated weights in the second layer, right? So we have updated all the weights. Now you have the same structure here again, and you have all the weights. And if you now do a forward pass, if you now perform a forward pass, you will get these values. You'll get y1 equal to 0.0159 and y2 equal to 0.98. Not yet. Okay, so okay, so if you perform the task with updated weights, your error is, if you calculate all the things, your error would be, actually I have done it with a code now, and then with the code I saw that, okay, yeah, so the updated error is 0.29102794. Earlier the error was 0.2983711. You can see that there is a difference in error, right? Okay, and then if you perform the updation 10,000 times, okay, update the weights 10,000 times, then you'll get your error as 0.000035, very less error, and then your values are 0.0159 and y2 is 0.9840. Now you see what were our target values. Target values were 0.01 and 0.099. So you are very close, right? Now the aim of this video was to tell you that, okay, we can perform the differentiation. It's not like very complex, but you see the amount of work which we have to do, right, in calculating all the derivatives. So we need to have a well organized process which is called auto diff, right? Auto diff is what is the process of automatic differentiation which is being used in back propagation, right? So that is what we'll be discussing in our next video. Thank you.